Welcome. Good evening. Happy to be talking to you guys today. We're going to do a little presentation on threat hunting, incident response, operational data. My name is Pete Anderson. I'm from ExtraHop. A little bit about me. So I went to University of Illinois in Urbana-Champaign. Back in the Stone Ages, like I'd never heard of the internet, and I showed up there, and it was when Mark Andreessen was in grad school there, and they had web browsers on all the machines, and I'm like, this is insane. What is this? So that was kind of neat when I went down there. I am a transplant from, if you're a Game of Thrones fan, Beyond the Wall or the Frozen North, Chicago. I've lived down here about 5 years now. I live just north of Charlotte. I started my career as a network consultant. I used to have all the Cisco certs and my NT 4.0, that's how old I am, certs, doing that kind of thing. And I've been doing network application analysis, and that encompasses everything from security to operations, troubleshooting, why is it slow, why doesn't it work right, all that kind of stuff. I've been doing that for over 15 years now. So that's a little bit about me. Whoops, that is the wrong way. So, I mentioned Mark Andreessen. So he had a semi-famous quote back in 2011 that software is eating the world. And it turns out he was right. I mean, if you look, software is everywhere now. So a little funny personal story about that. We bought our house when we moved down here a few years ago, and we got this really cool GE fridge. Like, you put your water under there, you hit a button, and it has a sensor, and it fills it automatically. It's kind of neat. Here's the weird thing about it. About every 3 or 4 months, I have to unplug it from the wall for about 30 seconds to get it to reboot the firmware in the fridge. So my fridge has to be rebooted like every 3 or 4 months because it stops working right. Right? So I think that kind of goes under software eating the world, right? It's like on everything now. So our CTO and founder, Jesse Rothstein, he's semi-famous because he's the guy who came up with the whole F5 load balancer application delivery controller. He had a quote last year that data is eating the world, right? That's sort of the new thing. Software is eating the world. Now all this data that software is producing is eating the world, right? We're just drowning in data. I'm sure I probably don't need to tell a lot of you guys that who get inundated by all kinds of alerts and data all the time. But that's sort of the new challenge, right? Software is eating the world. Now data is eating the world, right? And if you look at a lot of the most innovative and successful companies, like Google and Amazon and Apple and other companies, they're the ones that are able to derive a lot of value and intelligence from their data, right? Like, everything is about data now. If you look at all these social media companies like Facebook and everything, it's sort of the, what's the saying? If you're not paying for the product, you are the product, right? So all that data is extremely valuable, and that's how they make all their money, is extracting value from that data. So a little bit about the scale of data. So what kind of scale are we talking about? So it's in zettabytes, and a zettabyte is 1 trillion gigabytes, right? So this is sort of the growth of data at rest in the last, 15-ish years or so. So it's a very high compound annual growth rate, 43%. So we've gone from back in under a zettabyte in 2005, and now we're up, current time probably over 33 zettabytes of data at rest, and it resides in various different places: data lakes, puddles, ponds, whatever you want to call them. So that's a lot of data, though. So how much is a zettabyte? As I said, it's 1 trillion gigabytes. So a zettabyte is about 20 billion Blu-rays worth of data, right? So the 33 zettabytes would go around the Earth about 20 times if you stacked those Blu-rays, right, and had them go around the Earth. And if you were to download all this data over, say, like a 25 megabit per second connection, it would take 1.8 billion years. So long story short, a lot of data, right? Now, so that's data at rest. The other thing we talk about a lot, and I think this is a lot of times more pertinent in the operations world, is data in motion. So this here is a chart of the Cisco's estimate of global IP traffic. And there's also a lot of that. So that's all the data flowing all over these networks all over the place, right? And that can be anything from media, it can be transactions, it can be all different types of things. And there's about a 26% compound annual growth rate according to their estimates in that. So that's, it's not 33 zettabytes, but it's still, a lot of data here. And this data here, this data in motion, there's a lot of insight that can be extracted from that. And a lot of what I'm going to talk about tonight is extracting value from all this data and extracting insights from it and helping out with operational issues. So how do you handle these different data types, right? So if you think about data at rest, this is something that I think people have been doing for quite a long time now. A lot of the most innovative companies, have been doing a lot of BI, business intelligence. If you're like UPS, the famous story about them, isn't it that they eliminated all the left turns and saved tens of millions of dollars a year in fuel savings or something like that, right? So there's been a lot of business intelligence and value derived from analyzing data, and most of that's been data at rest. And the way you analyze data at rest, and that's the top tier, is batch processing. So you're going to take all your data, store it somewhere, and then you go back through it with some kind of software and do extraction, do analysis, do those types of things. Now, data in motion is a little bit different because a lot of times you can't even write it fast. It's coming in so fast that if you were to write it all out and then go try to analyze it, it's too late. Like there's just more data to analyze and you'll never catch up. So with data in motion, we want to do stream processing, and we want to analyze the data in real time, right? And that's a lot. Again, that's a lot of what I'm going to talk about tonight, which is the real-time analysis of operational data by doing stream processing. And that brings us to network traffic analysis. So this is kind of funny. I was talking to a couple of people outside. This was a term coined by Gartner to describe sort of this emerging space in the security market, and now they have decided that they want to call it network detection and response instead, right? And I think that's sort of to match the endpoint detection and response, right? Or maybe they just want to have yet another magic quadrant or category. But the idea here, right, is being able to do real-time data extraction and stream processing of data flowing over the network. Right? And there's some different things that go into this, right? So there's a big scale problem, as we went over on the first couple slides. There's an encryption issue, which I'll talk about in a little bit more detail here in a minute. There's the cloud. So that's, everybody's sort of in the hybrid cloud now because you've probably, if you've read anything about, people adopting Amazon and Azure, there's been a lot of adoption, but everybody gets stalled somewhere along the way, and then they end up, with one foot in each department. So that's actually something that I may have a little aside about because there's been some pretty exciting announcements for both Amazon and Azure in the last few months that's made it a lot easier for people to do network detection response, network traffic analysis, whatever you want to call it, in those environments. Essentially, they're allowing people now, they have a feature that allows them to tap in to all the network data. So if you host a bunch of applications up in one of those cloud environments, you can just tap into that data and send it to whatever analysis platform you would like. So that's something there's been a pretty major advance, and that's pretty new stuff. That's been announced, I think, from both in about the last 6 to 12 months. So that's a pretty major advance there. So let's talk about some of the challenges to doing network traffic analysis. So encryption. This is something that's grown a lot in the last few years. So you guys, if you're as old as me, you probably remember when there were no HTTPS web pages and everything was clear text and you just went out. Now, something like, and these are statistics from Firefox, something like 80 to 80+% of all web pages are encrypted, right? So it took about 20 years to get from nothing to 40%, but in the last 3 years, it's only the next 40% has gotten encrypted, right? So data in motion, as we mentioned earlier, is growing faster and faster and faster, but it's also a lot more of it is encrypted, right? And there's going to be some subtlety we talk about there as we go. And sometimes, if you own the data and it's encrypted, there's things you can do about that. Now, when other people encrypt the data, unless they're using bad encryption, which hopefully they're not, you're only going to be able to look at the outside of the data, right? So we'll talk about those couple different scenarios. And adding to all this, a little bit more of a detailed topic, but adding to all this is the new TLS 1.3 standard, right? And I'll talk about some of the reasons that it's come out and why people would care about it. But if you look at the timeline there, I actually was looking at this yesterday when I was looking at these slides, and was kind of laughing. I didn't realize SSL 3.0 was so old. You would not believe how much of that I see in customer environments all the time. All the time. And I'm not talking just internal. I find public-facing stuff that supports SSL 3.0. Although my most terrifying one, about a year and a half ago, I had a customer with their Outlook Web Access Server was still supporting SSL 2.0 connections, which I looked it up. I think you can spend like $400 on Amazon and crack it in like 3 hours or something like that. So it's kind of interesting how it's progressed. You know, we'd like everything to be on TLS 1.2, 1.3, but there's a lot of older things out there still, right? So back, though, to talking a little bit about TLS 1.3, probably the most important thing on that list is perfect forward secrecy. So I'll leave that to last. So some of the features, why is everyone adopting this? So number one, the faster handshakes. So why do you think that's getting adopted? So in TLS 1.2, you need 2 round trips to establish an SSL connection. TLS 1.3, with fast start and TCP fast open, you can do it in 1. So why does everyone care about that? Loading your ads faster. And I'm not joking, that is actually one of the major motivations behind that. Some of the other things, they've removed some of the obsolete ciphers, so things like RC4, triple DES, obsolete hashes like SHA-1 and MD5. Some of the more problematic options, if any of you have ever really gotten into the weeds on this stuff, you've probably noticed issues with renegotiation and things like that before. They've added downgrade protection. They're encrypting more of the envelope, like the certificates and the hello. And then, as I mentioned, probably the most interesting and important thing here is this property called perfect forward secrecy. That's doing analysis of network data. It's going to make it more difficult. So for any of you who have experience with this, the way we've always been able to decrypt data has been pretty easy, right? Like you have servers, they support encrypted connections. So you get the certificate, you load it up on some appliance on your network, right? And it man-in-middles all the connections and decrypts the data. That is no longer possible with TLS 1.3. And in fact, it's not possible with a lot of TLS 1.2. So these perfect forward secrecy ciphers are pretty common in TLS 1.2 now. So for those of you who, if you want to hear a really nerdy thing, if you've ever seen, an elliptical curve Diffie-Hellman key exchange or cipher, that is what that perfect forward secrecy is all about. So what does that mean at a high level? So you can't just load the key and get the man in the middle. So every single conversation, and there's hundreds of thousands, millions of them, right, just for an individual application sometimes, has its own key. And to be able to decrypt that, you need to get that key for each individual conversation. So that's been a big challenge. One of the things, I don't know if anybody followed sort of this adoption curve, a lot of the big financial institutions were dragging their heels on TLS 1.3 because a lot of them do a lot of decryption internally, and it makes it much more challenging to do that, which is, I'll talk about a little bit more in the next slide here. But this is a little bit of adoption, and this is from last year. You can see that adopting TLS 1.3, it's pretty well underway, right? So people, within 6 months already underway, huge percentage of organizations, right? So this is something, and I'll give you my little extra hot pitch now, since I do work there. If you guys, something you're running into, something you're thinking about, this is something that we've actually been pretty far ahead of and been thinking about for a lot of years, and we've actually already have some ways to do decryption on this kind of traffic, and we do it in an out-of-band fashion. So that's something I'd be happy to talk to anyone later on about that, because that's something that it's pretty important. A lot of, I think, vendors who have forever, all your IPS, IDS, a lot of times you need to do decryption. They've kind of hidden their head in the sand because it is a harder problem to solve, right? It's not as simple as just loading up your certificate. So what's the other big problem with doing this type of analysis, extracting data from the network? It's scale, right? And I've talked about scale a lot. We started out with the zettabytes and the 1.8 billion years and all the Blu-rays, but network traffic has just grown immensely, right? When I first started, we had 10 megabit per second hubs and things like that. In fact, in college, I had the old coaxial cable with the little T connectors and all that stuff. Now everybody's got 100 gig, 40 gig. There's more and more data. And being able to process all that requires a lot of horsepower. It requires good software engineering, right? It's sort of like the same idea with logs. I mean, you guys know how it is. You get more and more servers sending more and more logs. It requires more and more storage and processing to handle all that, right? And if you try to write all this stuff out and then do the analysis later, it just doesn't scale. So I have funny meetings where somebody who's, will say, hey, we got some requirement that we need to capture all our packets and keep them for 30 days. And I'll say like, okay, so how much traffic do you think you have? And they'll say, oh, I don't know, 5 gigabits per second. So you can literally type this into Google. You do 5 gigabits per second to terabytes per week, or petabytes per week if you want to be funny. And then it comes out, I don't remember the exact number for that one. It's some giant number, and they're like, oh yeah, we're not going to do that, right? Because the storage would just be absurdly expensive. And I love, by the way, Google, you can do lazy stuff like that. It's wonderful. So a lot of what we want to do, right, is we need a way to do this in real time. And if you think about the historical way people have done this, a lot of security has been focused on the perimeter, right? And with good reason. I'm not here to bash on, protecting the perimeter. We need to protect the perimeter. I did a proof of concept, actually. It's crazy what's out there. I did a proof of concept for a mid-sized city in North Carolina. And they have a municipal website. It does permits, zoning, things like that. What percentage of their traffic do you think was from China and Russia? 65%. And these are people the website is literally there for garbage pickup, zoning, as I said, permits and stuff like that. And they're just getting bombarded all the time by, all these automated things in China and Russia just looking for vulnerabilities and things like that. So we definitely do need to protect the perimeter. And that's been the traditional approach, right? Firewalls, which you got to have firewalls, although I'm somewhat skeptical of the 1 firewall is good, 2 firewalls are twice as good, 3 are 3 times as good. I'm not sure that really scales that way. But you definitely need good firewalls. There's been a lot of IDS, IPS type things, which are more signature based, right? So we're basically looking at a packet, looking at traffic, and looking for signatures, right? Known bad things, which can be valuable. I think like a lot of security approaches, it's one of these things, I don't know, I don't think it's been that successful since, we keep seeing more things in the paper all the time. But it's sort of like you need a virus scanner too, because, old malware is still bad. Even like you don't want to get hit because, I had, what was that one? The Eternal Blue exploit. So I had a customer that got reinfected by that last December because they had an environment that I won't go into all the details, for various different reasons they couldn't patch and turn because it was old software required like SMB version 1. They couldn't turn it all off, and it all got reinfected last December, even though it had been out there for like a year or something like that at that point. So, you still need that signature-based stuff because you got to stop the low-hanging fruit, right? Another thing that people use sometimes, because it is a little easier to handle the volume of it, is NetFlow. And NetFlow is not useless, but it's also not particularly useful. It's better than nothing. It'll tell you who's talking to who and how much, but it doesn't tell you much beyond that and doesn't give you a lot of context, right? So I would never tell someone, don't collect it, but it's probably not going to be enough for a lot of what you want to do. And it's certainly not, the more modern concepts of NTA and network detection response.
It also matters which NetFlow.
Yes, that's true.
Versions out there, everybody says NetFlow, but you got to ask.
That's true. So it's a good point. It matters what version of NetFlow you use. Also, sampled NetFlow, in my opinion, is very, very useless, but that's another topic. And I say that not just because of the concept, because I've seen it be like totally wrong in practice. So anyways, the scale, right? You got to be able to handle the scale. So here's the good news about all this. There's all these threats out there. There's way more data. We got to look through all this stuff, but computers have gotten a lot faster, right? So we're able to do real-time stream processing now to process all this data and extract stuff at very, very high speeds, right? And that brings us to this whole concept It's actually interesting. So I've been doing network packet analysis and this kind of stuff for, I don't know, 15 plus years, as I said earlier. But this whole concept of wire data is actually something that ExtraHop came up with even before I started working here. And it's an interesting concept because it's taking a lot of what us human analysts would do ourselves and automating it, right? I've been able to go in, some of you guys probably use Wireshark and things like that, and you can pull out data and things like that, but being able to pull out these deep insights in an automated way, that's what we're really talking about with wire data. A lot of traditional network tools have focused on the bits and bytes, right? So stuff that's useful to a network geek like me and some other people. But wire data, when we talk about wire data and talk about both network traffic analysis and network detection and response, it's really about not just extracting, hey, who's talking to who, how many bits and bytes, maybe some round trip times and other networky stuff, but also all that application layer stuff, right? Which is really where all the business intelligence and logic lives. And so what do I mean by that? So what does wire data mean? So if I feed if I have traffic that's, it's got database traffic, it's got DNS, it's got file operations, it's extracting all that stuff, extracting every database operation, what query was passed, how long did it take, were there errors, who copied this, who accessed this file, what username was it, what share was it on, what DNS query, what was the query, was there an error, how long did it take, was there a timeout, all those things, right? And it's doing it in real time. So that's the whole concept behind wire data, right? And it's the idea is, it's this big waterfall of data. It's everything in your environment. And I think it hasn't been a completely untapped resource, but as a lot of you probably who have been boots on the ground probably know, it's been very hard to scale in the past, right? You always know, you got the few guys that are really experts in Wireshark and you have some weird problem or security issue and you pull them out and then they can look at it and figure out what's going on, but it can take a really long time. Even if you're really good at it, which I used to be, probably not so much anymore, but if you're really good at it, it can take hours, days, sometimes to analyze a single incident, right? So automating that and pulling it all out and being able to not just have a human go in and look for things and search it, but have machines do it is a very, very powerful concept. And it's in my opinion, and this goes beyond ExtraHop, this is just the general wire data approach, regardless of platform, is by far the best way and most powerful way to get visibility into an environment and to know what's going on. Right? So it's useful for all kinds of things. And it's really the ground truth in your environment. I was actually talking to some folks outside. I cannot tell you how many conversations I've had where I'll go in, we start looking at network data, and I'll say, hey, is this right? This database is doing this, or this server's doing this, and they'll be like, no, that's not how it works. It's not set up that way. And I'm like, well, the network traffic is showing it doing this, and they're like, no, no, no. And then eventually somebody leaves the room, runs out of the room, and comes back, and they're like, yeah, you were right. We had to go fix something, right? So that happens all the time. Environments are very complex. They're very dynamic. A little aphorism I use is every time I go somewhere, if I ask, so people are always asking me to look at applications, right? Both for security and for operational reasons. If I ask 5 different people how an application works, I get at least 5 different answers, every time. And it's not because people are lazy or dumb or don't know how to do their jobs. It's just because things change so fast. People are not always good with change control. There's different components, different teams working on things. And it's just hard to keep up with, hey, these are all the different components in these applications that have become amazingly complex. Well, this service-oriented architecture, there's so many different pieces. And being able to understand all that can be very difficult, right? So one of the easiest ways to do it is just to observe it and see how it works. It's interesting. So Kevin, who's in the back, my colleague, and we recently went to a dinner where an FBI agent presented who specializes in cybersecurity. And one of the questions there to him, they asked him, they go, because he gets called in and he was his reason for being there is he's like, not enough people call the FBI. He's like, if you get money stolen from you, we actually can get it back a lot of the times, but you got to tell us right away. But we asked him, somebody asked him, what is the number one thing that would help you when you go to help a customer? He goes, oh, that they understand their environment. He said, we go in, we get called all the time, and people don't understand their environment at all. They'll be like, we got hacked. And they'll be like, oh, can you tell us about the application architecture of this thing we got hacked? Nope. Don't know how it works. He said they might have some logs, maybe. And they're like, can you look at our logs? It reminds me of my old days when early in my career, somebody emailed me a 200 meg or something like that packet trace once, and literally all it said was, what's wrong with this? I'm like, I don't know. It's an interesting question. But yeah, understanding your environment, I think, is a huge problem. I mean, look at all these hacks that we see. People are unaware that certain components are out there, that they're vulnerable, how things are working. And you read about this stuff in the paper over and over again, right? So being able to understand all these things is important. There's a lot of low-hanging fruit. If you look at just like if you have to support a Windows environment, just knowing where like SMB version 1 is, NTLM version 1, right? There's all these things that have vulnerabilities. There's various remote desktop vulnerabilities, and just being able to see all that and understand where it is can save you a lot of time, much more than, hey, do I have the latest signatures to get the latest, malware? I think people would a lot of times be better served by spending a little bit more time focused on some of their hygiene, right, and reducing their attack surface. And that's something that network traffic analysis can really help you with, right? And you can see, I'm not going to read through all these, but I've been doing this both, I've started out more on the operational side, and I've been doing a lot more of the security side the last few years. Turns out, I'll be honest, and I don't know what your guys' experience with this, like operations and security are very, very similar. They just use different terms for everything. So like one side does troubleshooting, the other side does incident response, and they'll use words like forensics, but really a lot of it is very similar technical skill sets, very similar data types that you're looking at, right? So it's like, hey, I'm looking at my users. If I'm a security guy, I think, hey, are my login credentials compromised? Performance, maybe what's the user experience, right? Same thing with the database. If I'm on the performance side, I care how fast are the queries. Are there errors? If I'm on the security side, I might care who's logging into it, what data is being extracted, right? What queries are being run. And there's a lot of overlap there. But the data collection itself, it's very similar to the world of logs. As a lot of you guys probably know, I think, Splunk and some other companies, but Splunk in particular, they marketed it really well. They came out with this idea is we're going to collect all your logs and put them somewhere. And a lot of companies adopted that to start, maybe for security, maybe for break fix, or whatever, one use case. And then they find out, that data is really useful for all kinds of different things. And it's the same thing with network data, right? But you have to have it in a format that you'll understand. And I think the analogy with logs is pretty good. Now, logs are probably a little bit easier to understand in their raw format, but they're not really any easier to consume, right? Looking through a 1,000-line log file is not really any easier than looking through a 100 meg packet trace. There's a lot of stuff in there, that's going to take you a lot of time to dig through. But the concept is sound, right? There's just so much value in that data, and it's data that you already own, right? Just like you own all your logs, you own all the packets on your network. And you can get a ton of value out there. And ultimately, what we're trying to do is inform your decisions with data, right? And make data-driven decisions for operations and security. What? There we go. So this goes to data value, right? And this is a guy I work with actually came up with this, and I actually think it's very apt. It's something that definitely matches my experience, right? Having lots of data is good if you can easily get to it and a lot of people can use it. I'm sure a lot of you guys have experienced like, hey, we get this one tool and it collects all this stuff, but there's only one guy who understands how it works. So what happens when he goes on vacation and you need it? You got to page him, or you're in trouble, right? This equation, I think, has really borne out true for me over the last 15 plus years. Is we want to have lots and lots of data, but we need to make it easy to get to, right? And I think again, using that Splunk, SIM, QRadar type analogy, I think that fits there well. What was logs have been there forever. They weren't that easy to get to before. Who wants to log into 50 different servers and start looking at logs, right? Nobody wants to do that. So, hey, they're like, oh yeah, we'll centralize it, we'll let you search it, all those kinds of things. Same idea with network data, right? Nobody wants to sit and dig through Wireshark all day. Even when I used to do that stuff all the time. I mean, even if you're a nerd, it gets a little, it's not that fun to do that all the time, right? So you're gonna make it easier to do and allow a lot of people to do it. And I think a lot of it, one of the things that, from the operational side that I've found over the years is one of the things tons of companies struggle with is they have a help desk and they're like, yep, pretty much every call that comes in, like 80% or 90% of them go to level 3 escalation right away. Because the level 1 and 2 people can handle like this much, right? And as soon as it goes beyond that, you're bringing in your guys that you would rather have working on new projects and other things like that to do that, help desk handling remediation. Very similar to security side, right? You have your, how much can your level 1 SOC analysts handle versus the higher up guys? A lot of times, it goes past that little sphere and you're beyond that, right? So the other thing about data value is it depends on your role and the context. So a good example of this, so think about a database transaction. So a network engineer might care about the state of the network, how long it takes to transport the query and response. A DBA probably cares about how long did the query take to run on the server, did it throw an error, was it successful? Security team probably cares about who was the user. What was the client that executed the query? What's the nature of the data? How much data was exchanged, right? And really, we're collecting the same data, but there's different teams, right, that are going to look at it in different ways. There's also this concept of the value of data over time, depending on what you're doing with it, right? And here you notice that these two curves, you can read them, threat hunting and incident response. So incident response, you need like what just happened and you need it right now, right? Threat hunting, on the other hand, the historical data can be more helpful there. And you can see that there's sort of a place the curves meet somewhere between 30 days ago and today, right? So that data, again, it's going to depend on the age of the data. So really what we really want is we want real-time data and historical data and a way to navigate that data, right? And not have it be like, oh, 30 days ago, now I'm looking through this giant amount of raw data, right? And again, to do it with low friction. So this is sort of the goal here, right? Is we want to be able to handle both of these things, kind of flatten the curves and have them meet. But it's just another thing to think about is that you have to have a way to efficiently store and be able to search long-term data, as well as be able to access data right now when something happens. So this brings us to wire data, and this is probably one of my favorite slides because it shows where it fits in the stack, right? Because it's not the only thing. Like, I'm not here to tell you to throw out your SIM and stop looking at logs, because that would be dumb, and I don't want to be dumb. I'm not here to tell you not to use endpoint agents and things of that nature, because you need those too, right? There's anybody that comes in and they tell you there's some like single pane of glass that'll do everything, that's not true, and you should not listen to them. You need to look at multiple sources of data, right? And the three that we've found, and this actually is true not just for security, but for generally for operations, there's sort of three classes of data. There's agents and instrumentation, and that's everything from endpoint, your virus scanners, your security, carbon blacks of the world, all that kind of stuff. And on the operational side, it's things like app dynamics, right? And Dynatrace and those kind of solutions. Even SNMP is considered an agent, technically, right? And then you have your logs. Logs, I think, are pretty self-explanatory. We've had logs for probably longer than in fact, I'm sure longer than we've had packets. It's probably just about the oldest data source. And then wire data, right? That's everything that flows over the network. Now, what is the stuff we care about with wire data that makes it so useful? Number one, it's real time, which is useful. But probably the most important piece here is it's empirical and definitive. It is the only data source you will look at that is completely unalterable by an attacker or someone nefarious, right? It is the truth. I don't care what the log says or what something else says. Whatever happened on the network is what happened, and I say that because I've been doing this for 15 years, and it's 100% of the time, if I see something happen on the network, that is what happened. So, and I think that's the most important thing here. And it also can give you the complete context. So, if you look at like a log entry, and there's all kinds, and as I said, you need to look at logs because there's all kinds of things that get logged that never touch the network. But log entries more focus on what someone thought to write in there, whereas if you're extracting all the things that happen on the network, that's every transaction, all the things that are happening in the application, and it doesn't rely as much on what someone thought to log, right? I mean, I'm sure we've all been using an application before that had an unlogged error message and things like that. It's definitely the most holistic source of data. And I can tell you, if I was starting a security practice or an operations practice, it is the first thing I would do is have a way to look at my wire data, right? And again, this is a concept beyond Xdrop. It's just what is the best way to get visibility into your environment? To me, it's pretty easily wire data. And one of the things that's not in my bullets here that's important is it's also by far, in my opinion, the easiest data to get. Because, I mean, getting logs from all your servers, you got to deploy software, right, to forward the logs to a zillion different servers. A lot of times to get a pretty good wire data view of your environment, I mean, we'll go in and do it in an hour or two. As long as your network guys sort of understand where the traffic flows are, a lot of times we can just plug into a couple of switches, make a couple configuration changes, and we'll get a pretty decent view of the environment, right? We may tweak it over time, but it's very low impact. You often don't have to even tell application people. They're not even involved. You're not messing with anyone's server. They don't even know it's there, quite frankly. So it's a very low friction way to get a huge amount of visibility into your environment, right? But again, these are your three, like if you're in a SOC, these are your three pillars of how you get data. And you should look at all three, right? And I'm sure I'm telling a lot of you things you already know. I mean, you need endpoint protection and looking at logs is valuable and all those things. But yeah, that whole thing about it being empirical and not self-reported, that is an important thing. And that goes back to that stuff I was telling you guys. Hey, I asked 5 people how the application works, get 5 different answers, all those different things. What the network says is the truth. The guy, I've had another one. I had one where they're like, we bought this new database server and it's totally not utilized. So, we plug it and turn on. I go, well, I don't see any database traffic to that one, but I see a bunch to this other one over here. What's that? They're like, oh, that's the test database server. I'm like, well, is it supposed to be going to that one? And the guy goes and looks. He's like, oh, we forgot to change the connection string when we deployed to production. So, that kind of stuff happens, and the network will give you the ground truth on that. So this is a quote from somebody in the NSA who agrees with this, right? So he said, their worst nightmare is that there's an out-of-band network tap that's capturing all the data, understanding anomalous behavior going on, and somebody's paying attention to it, right? So unlike a log, can't be disabled by an attacker, can't really be evaded. Any kind of exploit, modern exploit, compromise, breach, all involves doing something over the network. And there's no way they know they're being watched because it's completely passive. Now, it is important, though, the last thing there, that somebody's paying attention to it, that is important. Because as you guys know, you can collect all the data you want. Nobody ever looks at it or looks at the findings or the detections. It's not going to help you that much. So another fun thing, by the way, this actually still is the case, even from when we made the slides. So if you want to go test this, you can type human capital crisis, and it will say in cybersecurity as the first result. So this is another thing that, and this is when we're going to get to the next topic, which is a little bit about analytics, is do you have enough people? So I probably don't need to tell you guys, there's negative unemployment in cybersecurity for SOC analysts, all those things. There's simply not enough people. I'm sure that's why some of you are here, part of this, because it is a great field to get into. If you like hanging around with nerdy people like me all day. But it is true, there is a huge problem. And if you talk to any CISO, this will be one of the first things they talk to you about as one of their biggest problems. So there's a lot of tools out there, a lot of data. So why are we doing all this? Why are we talking about all this? Because still, you know how long it takes to identify a breach still? Average time, and this is for people who are actually willing to report it, 100 days. 100 days. And I'll be interested, that Capital One that just came out, I'll be interested how long it took them to find that out. I guess it's easier when they're bragging on social media, like, hey, I hacked Capital One, ha ha ha. That was kind of dumb, but hey.
Well, many times they don't want to say it. They don't want
Oh, I'm sure. So one of the things I always tell people, I'm sure for every breach I read about in the paper, and I think public companies have to report them under certain rules. I'm sure there's 2 you didn't hear about from private companies. And then there's a bunch that I bet you people get breached and hacked and never find out. They never know it even happened. I can tell you I've worked with some organizations where I'm sure that's the case over the years, right? So why does all this happen? Alert fatigue, right? Detections. You guys, I probably don't need to tell you about this. Average 5,000 alerts per day, right? Which I don't want to look at 5,000 of anything a day. 56% get investigated, 28% are legitimate. So 44% of SecOps managers say they see more than 5,000 alerts per day, right? So again, I'm sure you guys have seen a zillion slides that show statistics like this. We all know there's a problem, right? You know, there's, like I said, it's the whole like, hey, I'm going to deploy 3 firewalls or 4. Apparently, you know, that approach has not been working. So what's the solution? And I'm waiting for everyone to sigh and laugh at me now. Machine learning, right? It's magic. But it really is. A lot of using machine learning and AI to help us with this is the answer. Now, the problem is, and this is something we'll talk about, there's been a lot of hype around machine learning, and every vendor, like I feel like my next toaster is going to be advertised with machine learning, right? Like everything has AI and machine learning now, and I think they're terms that get thrown around a lot. But there is a reason for that. It does hold a ton of promise. I mean, some of you guys probably have the newer cars that basically drive themselves. You know, I'm not even talking about a Tesla. My little Honda like basically drives itself as long as it can see the lane lines. I mean, AI and machine learning, it does a lot of amazing things. There's a ton of promise there. And one of the things that's really moving the needle on that is the amount of processing power available in the cloud, because it does take a ton of CPU to do a lot of effective machine learning. But now it's easy. You just go on Amazon, spin it up, away you go, right? Now, this is, so I was showing this to my kids earlier. This was their favorite slide, if you can see it. So AI is hard, right? This is actually, believe it or not, you guys are laughing. This is actually like a real example of why AI is hard, like Chihuahua or Muffin. And this actually is interesting because it's an example of a problem that humans, like we can all look at this, or at least for most of them, and be like, oh yeah, Chihuahua Muffin, Chihuahua Muffin. It's very, very difficult to build software to do that. Very difficult. And if you want some more fun ones, we have, I think my favorite is parrot or guacamole, but we have, you know, labradoodle or fried chicken. Sloth, or I forget how to pronounce it. My wife took French and she told me how earlier today, and I already forgot, so. See, I knew we would have someone. But so this is an example, like AI can be really, really hard. Now here's the good news. Like the type of AI I'm talking about, which is more analyzing, doing machine learning on time series data, performance data, security type data, that is much easier than figuring out if a picture is a Chihuahua or a muffin or not, right? It's basically taking, all we got to do is give it a little bit of human context, and it can just find anomalies in the data, right? And the whole key to this is the nature of the data, because you can't even read that. It's a zillion different machine learning algorithms, right? So one of the things to note about machine learning is there's no secret algorithm. Like, I'm gonna tell you right now, like XTRAP, we have some good data scientists. We don't have like some secret algorithm that nobody else knows about, right? This is a very well understood field in computer science. Now it's important, you have to have some people who understand it well enough to apply the right algorithm to the right problem, but it's not like there's, you know, some secret, you know, Skynet, you know, algorithm that makes the best AI, right? It's a very mature space, actually, conceptually. Most research so far, interestingly enough, and this probably won't surprise you when you think about it, has been devoted to natural language processing and classification, right? That's how your Google can understand everything you say, right? Which is actually pretty amazing. And there's been a less focus on time series data. And the most important part is the data. So interesting quote from the director of research at Google. They asked him about, you know, how, you know, it's kind of amazing. I go in Google and like, because I'm old, I use Facebook. I type F and it just comes up Facebook, right? So it's like reading my mind. They don't have better algorithms. They just have better data. And that is really the whole key. Like 70 to 75% of the trick behind doing effective machine learning is having good data, right? And you have to be able to extract, you have to understand how to extract value from the data you have. So data extraction is actually the most important part of doing good machine learning, right? Because detecting an anomaly like this here, that's not that hard for a computer to do. Now, I can do it too. My thing is I can't look at 10,000 graphs in 30 seconds like a computer can. So the trick is if you have the right data in time series, you can get a lot of value out of it because finding anomalies like that is not that hard. Like, hey, this machine never accesses this file server and now it's read 10,000 files. That's interesting. Maybe I should look at that, right? So the idea is, instead of having to stare at 100 different dashboards all day, which I'm sure all of us have done, I know I have done at one point, is to turn the workflow on its head and let the AI or machine learning bring things to our attention, right? Hopefully not 5,000 a day. So the cool thing about this is the approach a lot of times has been, and I think I mentioned this, there's been a lot of approach around signatures, looking for malware and things like that. That's it's like whack-a-mole, right? Like I've done a lot of this stuff around ransomware. You know how easy it is for them to change one little thing around in their ransomware to evade a detector? It's very easy. But a lot of, if you look at breaches, a lot of the indicators of compromise inside the data center are the same regardless of the breach technique or malware that's used or the package that's used, right? And because and if you understand those indicators of compromise, you can build machine learning to look for them that's agnostic of a specific malware or breach technique that's used, right? Like, as an example, there's a zillion different Windows-based exploits, but a lot of them, hey, I see this machine now is, creating services and starting them on another machine, right? Or it's deploying DLLs on some other machine, right? I've unfortunately seen a lot of this stuff in real life, and those are some of the different things it does. But what you can do is sort of build models to learn how these services are typically accessed, things everybody has like Active Directory and databases and things like that, and then find anomalies when they're being accessed in abnormal ways. And if you look, there's been a little research on this. I think Verizon, they had a project they did, and they said 90% of all breaches fit one of 9 different patterns. Right? So there's some pretty good indicators of compromise that everybody knows about that we can look for. So a lot of this, now what's the whole key here? Is you got to look at the east-west traffic. And what's the problem with east-west traffic? Well, that goes back to the scale thing. Right? So a lot of, as I said, a lot of network-based analysis in the past is focused on the perimeter. The problem is, as I always tell people, it's like, you can spend $10 million on firewalls and the one idiot goes and clicks on the, cat.exe in their email and none of that matters anymore, right? So once they're infected or they're breached, everything bad that's happening is happening inside the east-west corridor, right? That's where all the critical assets are. That's where all these transactions are happening. So you need to be able to have the scale to be able to see all of that, right? And again, this goes back to having the highest quality data. That's why we want to get data out of the east-west corridor. Now, we certainly want to look at north-south data too. Although once you get to north-south, then it's like, well, that's the exfiltration phase. But still, it's important to look at that too, because there's all kinds of good stuff here. Good example of that is I was actually actively involved in a security incident that was in the papers here several months ago, where they got infected by malware, and it was so new that their endpoint detection couldn't find it. And they talked to the endpoint company. The endpoint company has to go and build a signature and all this stuff. So while we were waiting for that to stop it from spreading, I was able to use an extra hop to find all the command and control traffic. And it was interesting because the way we found it is it detected some anomalous SSL traffic. It was SSL traffic with no certificate subject. And I'm like, well, that can't be right. What legitimate company would ever do that? Right? And that's sort of an example. It's a simple example, right? But it's an example of ways you can look at network data and detect things that are abnormal, right? It's not necessarily like actual, it's not a signature of a malware, but it's something that shouldn't be there, and we were able to do that and able to contain the malware by cutting off all the command and control once we had identified it. So again, there's all kinds of indicators of compromise that happen. I won't read them all. You guys can see them over there: exploitation, recon, lateral movement, things like that happen in the east-west corridor. And we can get all that stuff if, if we have the scale to look at all the network traffic there. So the circle of life, reactive versus proactive, right? I think everybody wants to be more proactive, and it's like our nice goal in life, and then we're humans, so we're all kind of reactive a lot of the time. But one of the things that we think about a lot at Extra Hop, at least, is, look, we want to detect things and send people high-quality detections and do all those things. But I think that's like the total reactive posture. Like, hey, I'm going to run this security operations, and I'm just going to, like, I just want something to detect people attacking me and tell me about it, right? And that's valuable. But I think what people, and I mentioned this earlier, what they need to think about more is a lot more of this proactive. Like, how do we improve our posture? Because if you improve your posture, you understand, like, here's a basic question I ask people all the time in meetings. I say, can you give me a list of all the hosts that you allow traffic through your firewall to from the internet? You know how many people tell me they can tell me every single one of them? 0. They're like, oh yeah, we have this 5,000 line firewall config that gets changed every time some application doesn't work, and so, we don't have a list of all of those. So that's something that's very easy to tell if you have good network traffic analysis, right? And if you understand that, it helps you reduce your attack surface, understand your attack surface, and you're less dependent on being very reactive and waiting for something to, detect every attack or bad thing that could happen to you. So I think, detections, as I said, and all this machine learning is important, but just being able to be more proactive, understand your environment, even simple things. Like, a lot of people have network zones. Like, hey, A can talk to B, B can talk to C, but A should never talk to C. Like, why don't we set something up that tells us if A ever talks to C? And then we'll know if our policy is actually being enforced. Because let me tell you, that's another thing that doesn't happen all the time. I'll ask people, hey, do you lock down your DNS so people can only go through your DNS server? Oh, yeah, we do that. Most of the time, I'll go look like, oh, you have all kinds of machines going to 8.8.8 directly, going to Google's DNS directly. So it's important to not, it's sort of the old 80s trust but verify, right? Being able to understand your environment, understand your attack surface, and being able to validate that all your policies are being enforced. So finally, what are our goals in NTA, or network detection and response, as we've been calling it now? So we want to have comprehensive visibility, right? So that's the whole point of doing this. It is the best visibility you're going to get. It will tell you more about your environment than anything else. It will also give you definitive insights about your environment. So the data will be accurate. I have never seen packets that lie to me. So there's actually a saying, people say packets don't lie. I think one company I worked at, we used to have t-shirts that said packets don't lie. But the fact that we want to have the comprehensive visibility, be definitive, and then get immediate answers, right? Have real-time access to data, have it be low friction, and have it being able to be consumed by many people. And by this here, so I've been doing this a long time. And I've worked for a few different vendors that do various different types of network analysis. And I'll tell you, this last one is one of the biggest difference makers for how much value people get out of products. Because I worked for some companies before that had good products, but only like the two network guys could use it. Nobody else could use it. And it's amazing. When you have something that like 30 or 50 people can understand and get value out of, it's amazing how much more it does for that organization. Right? And again, I'm going to go back to that log analogy. It's the same thing with logs. If you have something that, can sort of make that kind of nerdy, under the covers data accessible to a broader audience, you get a lot more value out of it. And I think that is, like, as my take, these are all good takeaways, but that's one that I think is really, really valuable here. So thank you, guys.